Hi, today I'm going to be going over the valence bond theory and the crystal field diagram for FeCO4 CN2. Okay, this coordination compound is going to be an octahedral because there are 6, so 4 plus 2 is 4 plus 2 is 6, which is also the coordination number for this compound. And this coordination compound is also going to be a strong field ligand because of Cn and Co, which are both strong. Now I would like to show the valence bond theory for this coordination compound. Since this is a strong field ligand, it has to go through pairing energy and hybridization as well. Okay, so here's a valence bond theory for iron. Iron is going to have 6 electrons, so 1, 2, 6. This is going to be a D6 ion. And since this is a D6, we can force these two with this other two to pair up, which open up those two orbitals. And then we have 4s, 4p, and 4d. Now, since this is a strong field ligand because of cyanide and carbon monoxide, it would have to go through pairing energy. Since these two are going to pair up, it's going to look like this. And the hybridization is going to end up being an inner d orbital, which gives us d2 sp3. Again, this is going to be the inner d orbital. I forgot to mention that this is a ground state going to an excited state, because again, this is a strong ligand. Now we're going to go through hybridization, which is going to turn into the bonded state for this ligand, and we're also going to bring down the 6 electrons. This is also going to be the 3D. And then we have our 6 orbitals for the octahedral complex. And that's going to be D2 sp3. And the electrons would be from this ligand. So we would have 4 carbon monoxide sigma bonds and 2 cyanide sigma bonds. Now I'm going to move on to the crystal field theory. Now we're in the crystal field theory. This is going to be 3D. And the electron configuration is going to be the same as the bonded state. So since now this is a strong field ligand, this is going to have a large splitting energy. Because again, cyanide and carbon monoxide are a strong field ligand. Now these two orbitals are Eg, and these 3 are T2G orbitals. Now these orbitals are going to be dz squared dzx squared minus y squared dxy, dyz, and dxz. Now the electrons would move down here, which gives it a low spin because it is a strong field ligand. And it would take a lot more energy to move an electron up to one of these spaces. This species is going to be diamagnetic because of the paired electrons. And the splitting energy is a lot greater than the pairing energy.